Hello, it's Friday. How's everyone doing? I had a meeting run long, which means I had like fewer minutes than I had hoped. Oh, I did the thing with the camera again. Okay. Okay, I need to sort that out. Maybe that's a Monday thing. See, I'm not muted. Cool. People can hopefully hear me. Say hello in the chat. I see a couple people said hello in the chat. Welcome to Nick's Gang. Hello. Hey, Arya. Hey, Alexandra. Hi. Hey, Rem. Good to see you all in the chat. It's Friday. I didn't stream on Wednesday. I forgot it was Wednesday. But I also didn't really think about Ergot much between Monday and Wednesday, so you didn't really miss anything. But it's good to see everyone again. I mostly wanted to talk about doing something silly. So, I was thinking about this prefix addressing stuff. And at some point, my wife asked me about it, and I started explaining. And I was like, oh, I came up with a good way of explaining it. I said something like, hey, you can, let's say you live on a house with 100, or you live on a street with, like, less than 100 houses. You could just use the number. And then I go through the whole, like, prefix addressing type thing. And then, I thought I was very clever. I was like, hey, this prefix addressing seems pretty novel. This seems like a good, straightforward way to explain things. I'm very excited about this, feeling very clever with myself. And then immediately I got owned in the comments. Someone's like, hey, this is what phone numbers do. And I realized, yes, this person, Dell, is exactly correct. And literally all of the stuff that I have been describing with prefix addresses is literally how phone numbers work in most of the world, where if you're dialing a local number, you can use a smaller number. And then if you're trying to dial that number from far away, you usually put some kind of like area code. And if you're even further away, you have like a country code, and there's another prefix you have to add to this. It's literally phone numbers. So like very much all of my very clever thoughts about what I'm doing, I went back to feeling very silly. Well, I don't know. It's a mixed bag of feelings, because on one hand I feel very silly because for a while I was feeling clever, like I had invented something. And that's always a fun feeling to go like, oh, nope, I reinvented the wheel. Yeah, the gang reinvents phone numbers. Exactly. The other hand is that it actually makes me feel better because there's prior art. Obviously phone numbers are a thing, which means it's not that ridiculous of an idea. And so that makes me feel good that I'm not like running down a path that's going to suddenly dead end. Means that there's like a very clear prior art that I can go with on this. And it gives me like the best metaphor in the world to explain this. Because like anytime you invent something new and novel, the downside is you have to explain it to people, and you have to spend what I've heard people refer to before as the weirdness budget. And so you always have to, like, whenever you're coming up with new research stuff, you always have to keep your weirdness budget in mind, because the more weirdness you have, the more people are just going to bounce off. Some sickos are really going to love the weirdness. But, like, when you're trying to make it usable by people, the more weird things that you have to explain, the more likely people are just going to go, this seems too hard. I'm gonna do my own thing, or I'm going to pick something else. So, this is awesome because it gives me, like, a very clear, hey, how do addresses work in Ergot? They're basically like phone numbers. And someone goes, what? And you go, yeah. Depending on how far away you are, you use so many things, and you can use certain numbers to call your local area. And then, the further away, the more numbers you have to use. And I think that's a metaphor that people totally understand because they've had 10, 20, 30 years of training of, hey, this is how phone numbers work. So I'm actually really excited about it because it's a very simple way to describe it. So if you don't know what I'm talking about, sorry, I got very excited. This is what I talked about on the last stream, where we talked about this sort of like stable addressing scheme where when you're setting up a local network, you can only use a few numbers, and then as you kind of like zoom out, you use more numbers, and then even if you join a much larger network, if you're still talking locally, you can use this. And I was mostly explaining it with like base 2 numbers, because then it's very clear like how this is implemented. You're using some kind of mask, sort of like subnet masks. So this is where this original inspiration came from. But like I said, when I started describing it, I started using base 10 numbers because I was thinking like, describe to a human. And yeah, it became very apparent that this is basically just phone numbers. So this has some other cool things to it because like when we're sending things locally, which in a lot of cases might be your like most high bandwidth connection, or at least your most regular communication, it means that if we use a very like a varant, like Postcard makes integers larger than a byte of varant, it means that if we can be smart and use small numbers, like the smallest possible local area number that we can use, it will make headers small, which is awesome because it means like, hey, if I'm talking within some local area, we can just use two digits numbers to call each other, like if you're inside the building, basically, which means that your headers are relatively small and you only pay bigger expense when you're going further away, which is neat in my opinion. It meets all of our original goals of like, hey, if I have a small network of devices and I plug them into a much larger network, they don't need to renegotiate everything. They don't get interrupted and things like that. So Doc, I'm probably not actually making anything today. I'm just kind of talking about some ideas, but this is for a project I have called Ergot, which is a network stack and messaging library in Rust for embedded systems. So if that's interesting to you, then definitely come hang out. And if not, no worries. But we're talking about how we do addresses in that, because we do it one way and kind of proposing doing it. I'm kind of proposing doing it another way. Do varants mean that theoretically addresses can get as long as you want? Yes, this is a cool thing because the way that varants work in Postcard is that you can actually sort of paper over different bit widths, because a varant is the same whether it's a U16, U32, U64, U128. The thing I just say, and the one thing that Postcard does is it enforces, so for example, on a U32, the largest that varant could get is 5 bytes. So if we think that we're deserializing a U32, we'll never process more than 5 bytes, and if by the end of that 5 bytes we haven't hit the end of the varant, then we just say this was a bad varant. Which means that technically you could have one device that has a U64 address and one that has a U32, and they will work as long as you never try and send a U64 that is larger than U32 max to a device. So the answer is we probably could make it work in most cases, and then if you were smart and put like some kind of termination where you go, hey, I know everyone below me in the network only speaks 32-bit addresses, so at this layer I'm going to do some kind of translation or something like that. James, I have bad news. Ergot is now a proper global internet protocol. Maybe. The one thing that I don't have is this prefixing is all very hierarchical. Like, it is the DAG or the directed acyclic graph. I don't know how you would have redundant or loop links with this. Right now, I'll probably just tell you to not do that. But I don't know if those kind of links would work well in this system, which definitely won't work as a general internet protocol because almost always you want to have redundant links. Like, you want to, like, if you're, the biggest enemy of internet, a backhoe, cuts through your fiber underneath the street or in the dirt somewhere, you want to have a second link that's redundant that you can fall back to. Or you might even want independent like control plane links and data link planes and things like that. So there's still at least some stuff that I'm saying this wouldn't be a good, like I wouldn't recommend replacing your IPv4 or IPv6. Sibling router could still be a thing. Yeah, I haven't wrapped my head around that yet. So if you can describe how to do like multipath or redundant links or cyclical routing, there might be clever ways to get around that. And maybe the answer is you just like, that route exists, but you don't light it up somehow. So you don't end up like that one internet in the middle of the Pacific that lost internet for months due to a volcano. Yeah, the kind of stuff that you would absolutely do in a robust network of internets, you wouldn't do on a circuit board. Like, your circuit board's probably not going to have a fallback link because you don't really have, you don't worry about what happens if someone cuts the trace on the board. You just say, that's a broken board. And even in cases where you're like, well, we technically could have a lower bandwidth fallback, you get into some problems of like, oh, we were using a 12 megabit per second USB line. The fallback is like a, 10 kilobyte per second serial line, all of a sudden nothing works anymore. Like everything falls over. So I think you have bigger problems if you need redundancy in your network. Also, I don't think would work with things like mesh networks where you're like constantly renegotiating what the shape of the network is. So yeah. Yeah, stop cutting the wires on your board. Don't shove a screwdriver onto your board. 2 routers can just share an address subnet. I guess the decision how to decide on the route is then a different problem. Yeah, this is like spanning tree protocol type stuff, which maybe we'll get to. I keep saying we're not going to deal with these things, and then we sort of, get to a point where we're dealing with these things. So I don't know. Good problems to find out. But this sort of achieves my primary goals of I want to be able to have... And the thing is, like, there are also some other downsides of this, and maybe we'll get into them, but, like, the biggest sniff test is that when you have an independent network on a board like this, like maybe there's like 5 microcontrollers or something on this board, or you have like one main CPU, a user interface CPU, and then like 8 motor controllers or something like that, that when these exist not connected to an upstream network, they can operate autonomously in a way that makes sense for a small device like this to do. But then you can plug it in so that you can get like telemetry or uplinks or even just connect it to the internet, and it's connected to a larger network of devices, and there's no hiccups. And I'm pretty sure I can do it in this. The one, like, I don't have an answer for this yet is right now this sort of assumes that you know what the max number of connections you have underneath you are. And for a device like this, you might just say, hey, like it's 64. Cool. I know I'm never going to plug something into it with more than that. But then the question is like, oh, I want to be a bridge for something. And I said that this could handle 64 devices. I'm holding backside. This is my PicoCalc, which is my favorite prop right now. And then I plug in something that has a network that has 100 more devices in it. And what happens if I said that I never need more than 64 at this layer, and then all of a sudden I have more than 64? And I can probably imagine a world where we can renegotiate upwards. We might cause some disruption above us because we're kind of like reallocating numbers and stuff like that. But I think it could be solvable, but it might have that sort of hiccup disruption that I didn't love. But I am going to say Ergot, in most cases, is not a general purpose internet protocol. And when you're building a board like this, the max is going to be like, I don't know, if there's 5 microcontrollers on this board, you might say, okay, we'll call it 16. And that even gives me some headroom and stuff like that. Arya is saying, I'm working on a proposal for how to seamlessly expand the number of devices. That sounds cool as hell. I'm very interested, Arya. I need to write up what I have already, which is sort of this with the context of phone numbers. So I'll try and open up a discussion this weekend. But if you have ideas of how to do that seamlessly, that would be very cool. Like expanding the address space to the left. Yeah, so I mean, like, I could definitely think of things that you could be clever about, especially if you took advantage of the space. Like if you're a device that's giving out chunks to everyone underneath you, even though they ask for 64 devices, you might space everything out by 8,000 devices. And so that way, if someone asks for this becomes like a block allocation problem. So actually, like, we kind of get into like general allocator strategies or like, buddy block allocators versus things like that. With the one downside is that there's always a pressure to keep the numbers as small as possible, because the smaller the numbers are, the better those, like, the smaller your phone numbers are. Because if you go like, okay, well, there's these could be like number 100 to 200, but if we go, oh, we space everyone out, so all of a sudden every phone number is 5 digits at the least, then we might lose some of that compactness benefit to it. But it's a trade-off. Like, it might even be something that we do at each device level, where we say like, hey, devices that have more bandwidth and are more flexible and they don't care about the difference between 2 bytes or 4 bytes in the header, they'll space everything out, because then they can always be very permissive and let hiccups underneath them get sorted. But for like little devices that very strongly know they will never give out more than 64 addresses because they don't have expansion ports or something like that, they just do everything super compact. Yeah, Alexander, you probably said it before I said it, but yeah, just like the allocator. Hey, can I have 8 bytes? Sure. Here's an 8 kilobyte block. Exactly. Offsets could make sense. Maybe not, because I think sort of this assumes that there's... Well, yeah. I mean, you might be able to, like, move people where they thought they were occupying the beginning of the range, and you move it, and now there's still a consistent block just in the middle of the range. Could be an option. I think we definitely should write down what the rules are. Maybe having multiple addresses for a device. Like in most cases, you don't need to speak with the sub-device. You could overlay it, but it's just like, I don't... Basically, it comes down to, can I write down the rules of how this should work so that I can implement it, and then if another device comes along, someone else... stuff. Oh yeah, everyone watch the 1 Million Room Hotel by Faster Than Lime. Absolutely. Faster Than Lime is awesome. I have a podcast with them. Million Room Hotel. Let me bring this up. No, not Mr. Beast. 10 Million Room Hotel. Yeah, I've definitely watched this before. I forget exactly what problem, but this is like one of those famous problems in computer science kind of things. I'll have to go back and watch this because I remember vaguely what this is. Does it say what the name of the paradox? It's not a paradox or something like that, but yeah, I think it's how to do allocation stuff. But yeah, definitely go watch Faster Than Lime's videos. Faster Than Lime's awesome, or Amos is awesome. Also, shout out to our podcast together, sdrpodcast.com. Your weekly treat. We haven't started recording new episodes yet. Spoiler. But we probably will after Euro Rust in Paris, which is in like 2 weeks, where we're going to be recording 2 live episodes. So I guess I think we'll be able to publish those. If not, I might sneak in some microphones, but I think it'll probably get published. It may just not get published immediately. But yeah, Rem, definitely, like, if you have an idea, please write it out, because we will be able to discuss it more concretely in writing. And I know I'm saying this having not written out this plan, but right now my plan is basically phone numbers. So I'll write that down in more rules, and then we can kind of keep a coherent rule set there of like, even stuff like, what would you do in this case? And then making sure that all the rules are coherent in that case. So please do open up a discussion for this. I would love... Let me go ahead right now. I'm going to open up a discussion as a placeholder, and I will fill it in more, but this way people can start adding topics to discuss here. So, let's just do this of moving to a phone number style of... You can tell it's a long day. I can't type. But if we did addressing like neighborhoods do phone numbers. Okay, so discussion 143. Feel free to create child items for this. Aria, I think you had something. Rem, definitely feel free to just write down the notes and ideas here, and I'll try and fill this out as well. Inject more SDR into my veins. You can go back and rewatch them all, or re-listen to them all. Okay, and then the other thing that is an idea here that I actually sort of like the idea of, thank you, Aria, is to actually get rid of the concept of ports. So right now we have addresses, which get you to the device, and then we have ports, which get you a specific port or socket on that device, or in some cases the broadcast socket and things like that. This split kind of made sense, One, because AppleTalk and TCP/IP both do this, so people understand it, and it's like a common thing to say and understand. Two, it kind of separates the concerns, because in Ergot, addresses are mostly the concern of the profile, which is mostly your external interfaces and routing. Unless the address is like 0, which means local. Basically, like, addresses are a concern of the external interface, not the local net stack. So even when you send a packet to the net stack, the first thing it does is turn around and asks the external interface, is this packet for us or is this packet not for us? And if it's for us, then the external interface says, it's for you, buddy, keep it. And if not, then it takes it and tries to do something with it. So there's kind of a split. And then, like, when we're doing external interfaces, we don't really care about ports very much. We only really care about addresses. So, like, by the time that it gets handed back to the net stack, we only have to worry about the socket at that point, or the port ID. I've always... Right now, like, in Ergot addresses, we've got a 16-bit network segment. We've got an 8-bit device ID on that network segment. And then we've got an 8-bit port that is also the same. Or we've got an 8-bit port. So you have a total of like 32 bits of addressing in total. But I've always worried, because there's some cases, like if I wanted to use Ergot for like a cluster of computers, like not embedded computers, but like I have a data center or whatever, and I want them to all talk Ergot internally, 256 ports may not be enough. Like, you might have devices that have way more than 256 ports. And similarly, if you've got embedded devices, you might have embedded devices that are only ever going to have 4 ports. And so they're always sending a 1-byte port along the way. And basically, when I'm introducing all this stuff for, like, variable width numbers, the question is, why have a separate address and port? Why can't we say, like, as a device, we want to be able to have up to 256 ports, so we'll reserve that amount of space, and then up to 64 devices, and so this is just my address space. And you almost treat your socket space as if it was a child of yours with just a certain number of addresses and things like that. So the question is, this might actually compress better if we slap them all together. I actually do this in Ergot already, where I actually do the most significant 2 bytes are the net ID. The next significant 1 byte is the node ID, and then the least significant byte is the port, and that actually gets slammed together and then varented. But actually, if you ever have a network address, as in you're sending off the device, you almost always are going to have at least 3 or 4 bytes of address, which is kind of a bummer. Like, that doesn't squish down as low as I'd like it to. But if we slap this all together and you have cases where you only have a handful of ports and you're on a network with only so many devices, I could definitely see a case where you're maybe not under 1 byte, but you're under 2 or 3 bytes pretty regularly, and within the same machine almost always. So what I'm actually proposing here is we get rid of ports and we just have addresses. And so every socket gets an address. And so some prefix, maybe like, you know, starting with 5 bits of sockets, everything at that is just referring to the device. So in the same way that we divide fragments of the network, we divide the device into like children and local sockets, more or less. And in some cases, this, or like in some perspective, this makes Ergot addresses work a lot more like Erlang's PIDs than TCP/IP addresses. Because in Erlang, every task, basically, or thread or process, I forget what Erlang calls it, but it's similar to what we would call an async lightweight task, gets an address. And like every task is basically given an inbox, like a socket. And so that task's PID is like the address. And so anyone anywhere on the network can send a message to that PID, and it will be routed across machines and to this specific worker task's inbox. And mostly this is opaque. I think you can print it. I don't know if you can manufacture them. I've never really gotten that far into Erlang. I've learned a little Erlang just for like learning how other people do networking and services and stuff, but never really, yeah. But yeah, it's a process idea. I think maybe Erlang calls them processes, but their processes are not like OS processes. They're like I said, the closest thing that I can compare them to are like async await tasks, where they're like lightweight, cooperative. They're not really cooperative. They can be preemptively, whatever. It's a language with a VM. It's not going to map one-to-one with operating systems. Maybe a bit like Java's fibers or whatever. But yeah, it's an ID, and so it's mostly opaque, and you don't think about it, and you don't worry about it. And I kind of like that, actually, because then you don't have to, like, instead of having 3 things to teach people, like what is the network ID and explaining what a network segment is, what's the node ID and explaining what a node ID is, and what is a port and what a port ID is. There is address. Every socket gets address. Every device has like a prefix of addresses that you can use to talk to any of the sockets on that device. And then this whole neighborhood or network of devices has a prefix that refers to any of the devices in the sockets there. And so it becomes like a really coherent pool, which I like. So yeah, I'm thinking about putting that in the proposal as well, because I think it would compress a little bit better. It allows you to be dynamic and basically only have one slider of dynamic that you have to think about. It doesn't quite map as cleanly to both like external profiles and local sockets, but most of this logic of how to tell, like, is it in scope or out of scope is just like 1 or 2 bit operations. So the logic that could probably be shared in some helper functions and shared between both of them. So I'm not too worried about that. What else? And then, we can do the very IPv4 thing where our routing tables, instead of holding specific devices and then what interface to go in there, we can actually glom those together, where if you find that 2 prefixes that have some common part are both out in a single direction, you can just go, oh, that whole pattern must be in that direction, and you can do kind of like globbing of that, and it can actually take up fewer routing table entries if you're able to glob routes together. This is like what a lot of routers do for IPv4 and IPv6. So let's steal their ideas too. Also, hilariously, when I was writing my talk at for Rust China Conf, I used the word steal in a bunch of places, like let's steal these ideas from those people. But I realized, like, they're with translation and things like that, I was like, that's like an in-group joke. I don't know if people will take that well. So I actually changed all of them. It was to borrow. So if you see anything in my slides from Rust China Conf where I say like, oh, we're borrowing this idea, that was like a big find and replace at the last minute, because I went, steal might not go well over with an audience that both has like, it's not their native language. They're probably going through translation, and it's not like an in-group that would get the joke. But I went with borrow politely in polite company. But yeah, I refer to it as like stealing good ideas. Okay, so that's kind of where I'm at. I got humbled by realizing that I didn't invent anything. I just readapted phone numbers, except for now they're basically base 2 phone numbers instead of base 10 phone numbers. I'm starting to think it's a good idea. I haven't had anyone tell me that it's a bad idea. Borrow does fit well for Rust as well. That's a good call. Oh, someone had a question. Rem, you actually had a question. I could imagine also just having a book with patterns. I feel like a lot of things may not have general solution, but maybe a few solutions with different trade-offs. I totally agree with you. This is one of those things that I, like in the slides, I talk about 0MQ, and I really like 0MQ's approach to this, where they say, like, we don't litigate every possible thing you can do. We give you like 4 or 5 core building blocks that are really well documented and tested, and then you can come up with patterns on top of this. So like if you look, almost all of this book is just patterns and discussions of like, hey, if you're solving this kind of problem, this playbook looks or works pretty well, or like they call them like unprotocols or whatever, in that a lot of the times you don't hammer it all down to like you know, an internet protocol specification. You just go, look, we're going to do some pub sub here, we're going to do some of this here, we're going to do some of this here, whatever, throw it together, it works. And I very, very much identify with that approach to that, in that I don't want to litigate all 8 million things you can do with Ergot. I want to go, look, there's 8 building blocks, have fun, knock yourself out. If you want to do what I do, I like these patterns. So very, very much I'm stealing this ethos from Zero MQ. Like, I like that. And watching a lot of like Hinchin's talks and things like that has really hammered that home. So absolutely, you nailed it, Rem. I want this for Ergot. Like, I would love to have the e-guide or whatever for Ergot. Because I think that's a good way to solve problems. I won't be able to litigate the long tail of what everyone wants to do. But if I can give everyone like the 4 like chef's suggestions, then I think that's a good way of doing it. What else do I got? I don't got much else. Again, this week was really busy. I was catching up. Last week I was traveling for a good bit, so this week was kind of like catching up of the work that I should have started last week. And so I kind of worked a full week on client stuff this week and not a lot of Ergot. So we'll see if that changes. Maybe it will, maybe it won't. No promises. If anyone wants to write this stuff up in the discussion, I'd love that. If anyone wants to like just try moving everything over to a system like this, hell yeah, have my blessing. I do not need to be the one that does that. But I am, until someone says like, oh, there's some other stuff like broadcast. It becomes much easier to specify the scope of your broadcast when you can do like the upper bits are a broadcast address, which I think is very neat. This does get a little funky when we don't have a dedicated broadcast port anymore, because that's very load bearing in a lot of the current design. I don't know how I'm going to address that, but yeah, like I said, I'm probably going to keep moving in this direction until someone comes up with a reason why it's a bad idea. I'm at least going to start prototyping this and see if it works well for the current examples. Or if someone else starts prototyping with it, I would love that. Just maybe shout out so we don't step on each other's feet. I'll definitely shout out if I'm going to start messing with it. But yeah, I think I'm moving forward in this direction until someone shouts. If you can think of a thing that I'm not thinking of, please tell me. I would love to avoid stepping in potholes. Maybe make a broadcast protocol where you ask your router to broadcast it for you. Could be. Yeah. Yeah. Definitely, I think for more like less ad hoc, because what I'm doing now is more like multicast in TCP/IP, where a lot of things where people say pub sub or broadcast, they're really talking more about like negotiated protocols where you don't really just blast it out using a total wildcard. You either like individually unicast it to many people, or there's some other kind of way of setting up groups and things like that. So I don't know. Please write this stuff up. If you have an idea, please write it up. Yeah, we're changing something fairly fundamental, which means thinking through what we're changing and what new things are possible, but also like what old things are we going to have to find new solutions for. So I'm probably going to put in last call for comments, questions, well wishes for everyone's weekends. If you're watching this later in the VOD, thank you for watching. Leave some comments. I don't think we have like any YouTube comments, but I'm happy to keep putting these out because a couple people join and I like being able to refer back to them. So hit me up. Otherwise, I'm going to give chat like the 30-second delay to catch up so they can say hey or goodbye or good weekend or ask any questions, and then I'm going to go enjoy my weekend. So I hope you all have had a wonderful week so far. When I say so far, it's Friday. Make sure I didn't get anyone pinging me on Blue Sky. I guess no, we saw my notifications there. We checked chat. Don't think there's any in the Namas room. Lots of other stuff going on. But yeah, I'm pretty pumped about this. Oh, Rem Revo, you're Titanium Traveler. I did make that connection. Awesome. Cool. I have to give Titanium Traveler or Rem Revo credit for. This is another thing I need to write up is like the concept of like. Let me go pull up the Ergot docs of like the like generics bundling stuff. Like in NetStack handle of coming up with a way of bundling a bunch of generics together. This is a very cool and clever trick that Rem showed me. Yeah, no worries. I used to actually it was funny. My usernames were a mess for a while because for a while I was like, I shouldn't use my name. I should use a handle, and then I used BitShift Mask, and then I basically turned Twitter into my LinkedIn, and so everyone like associated with my real life stuff, and I was like, well, at this point, it seems silly to use an alias when everyone knows who I am. Like I've not been secret about this. So then I started switching everything to James Munns. I think now I'm mostly James Munns on everything. But yeah, there was a while where it was like a mix of weird handles. But yeah, I don't see anyone else. Super excited to keep talking to people. So come say hi in the Matrix chat. Don't forget that, let's see, let's go to the repository. If you go to the Ergot repository, don't forget to join us on Matrix. That's where I do my chatting all the time. So cool. Have a good weekend, everyone. Talk to you all later. Enjoy.